Now, dear student of class 12, now today I'm going to start the derivative, first order derivative of inverse trigonometric function. For inverse trigonometric functions that you have to use the substitution method. Now say, I'll give you some concept of substitution, how to substitute the trigonometric function in derivative to make it easy. Now say, suppose if it is in case of 1 minus x square, always substitute x equals to sine theta or cos theta. Like 1 minus sine square theta is cos square theta, 1 minus cos square theta is sine square theta. Suppose the question is in this form, a square minus x square. Then you have to consider x equals to a sine theta or a cos theta. These substitutions are important for integral. In integral calculus also, these things that you have to do. Now, if it is in case of 1 plus x square, then you have to substitute x equals to tan theta or cot theta. You may get the question in this form, a square plus x square. Then x is equals to a tan theta or a cot theta. This substitution that you have to remember how to apply the trigonometric functions. Now next is x square minus 1. Then you have to substitute x is equals to a sec theta or cosec theta. If it is in terms of x square minus a square, then you have to substitute x equals to a sec theta or a cosec theta. Suppose the question is in terms of this form, 1 minus x over 1 plus x. Then you can substitute x equals to cos theta or cos 2 theta. You may get this form also, a minus x over a plus x equals to, in this case, x equals to a cos theta or a cos 2 theta. And some other forms. Suppose the question is in terms of 2x square minus 1, this form. Then you have to consider x equals to cos theta or cos 2 theta. The same thing, 1 minus 2x square also, you have to consider x equals to cos theta or cos 2 theta. These are the substitutions which are important for derivative, and as well as this is important for integral calculus method of substitution. These things that you have to remember how to select the functions. And today we'll discuss these things in numerically. Now, I'll apply the substitution over here in this question. Now, this is y is equals to tan inverse of 1 over under root x square minus 1. Now, trigonometric substitutions that I'll apply over here. Now, if it is in terms of x square minus 1, either you have to consider x equals to sec theta or cosec theta. If I consider this is equals to sec square theta minus 1 is tan square theta. Under root tan square theta is tan theta. 1 by tan is cot. But by the method of substitution, or with the help of substitution, I'm trying to convert this quantity in terms of tan. If I consider this is sec, this one will be in terms of cot. That way also we can do. But if I consider the cosec, we'll get the proper substitution over here. Let x is equals to cosec theta. Now then I'll substitute over here. Y is equals to tan inverse of 1 by under root cosec square theta minus 1. Y is equals to, it's a formula, 1 by under root cosec square theta minus 1 is cot square theta. Y is equals to tan inverse of root n square get cancelled, it is cot theta. 1 by cot is tan theta. And you know about this property, we did these things in inverse trigonometry. Tan inverse of tan theta is tan inverse of tan theta is theta. Then what will be the value of theta from the substitution? That you have to bring cosec over here. X equals to cosec theta. If you bring cosec from right hand side to the left hand side, it will be cosec inverse x. Now sir, x is equals to cosec theta. If you bring this quantity over here, then this one will be cosec inverse x equals to theta. Now in place of theta, now we can write cosec inverse x. Now then the derivative, differentiating with respect to x. This is dy by dx. Derivative of cosec inverse x is minus 1 over x on the root x square minus 1. This one is the proper answer by method of substitution. Now y is equals to tan inverse of under root 1 plus x square minus 1 over x. Now for this particular one, this question is very important. I'll consider let x equals to tan theta, and this particular problem, it has got lots of concept, trigonometrical concept of class 11. Tan inverse of under root 1 plus tan square theta minus 1 over tan theta. Now y is equals to tan inverse of 1 plus under root 1 plus tan square theta is sec square theta minus 1 over tan theta. Under root sec square theta is sec theta minus 1 over tan theta. Now then I'll try to convert this quantity to trigonometric form in terms of tan. Sec means we can write 1 over cos theta minus 1. Tan is sin theta over cos theta. Now in the numerator, LCM is cos theta. Y is equals to tan inverse of 1 minus cos theta over cos theta divided by sin theta over cos theta. Sin theta over cos theta. Now after taking LCM, now we can cancel this cos. Now then, next step is very important. The formula that you have to remember, the multiple angle that I'll use. 1 minus cos theta is 2 sin square theta by 2 divided by sin theta is 2 sin theta by 2 cos theta by 2. To get cancelled, one sin and the sin get cancelled, and what remain over here? Tan inverse of sin theta by 2 over cos theta by 2 is tan theta by 2. Then y is equals to tan inverse of tan theta by 2 is theta by 2. So we can write 1 by 2 into theta. Now from the substitutions, what will be the value of theta? X equals to tan theta, then theta is equals to, if I bring this tan over here, then this one will be half of tan inverse x. After that, the derivative after this multiplication, differentiating with respect to x, dy by dx equals to half, and the derivative of tan inverse x is 1 by 1 plus x squared. Then the proper answer we can write in this way, 1 over 2 into 1 plus x squared. This substitution as well as this numerical is important for the boards. Now y is equals to cot inverse of under root 1 plus x square plus x. For these functions I'll consider let x equals to cot theta. Then y is equals to cot inverse of under root 1 plus cot theta or cot square theta plus cot theta. Y is equals to cot inverse of under root 1 plus cot square theta is cosec square theta plus cot theta. Y is equals to cot inverse of cosec theta plus cot theta. Now I'll try to convert this one in terms of cot. Y is equals to cot inverse of cosec means we can write 1 over sine cot is cos theta over sin theta. Now then I'll take LCM over here. Cot inverse of, if I take sin theta LCM, this one will be 1 plus cos theta. Over here also I'll apply the formula of class 11, submultiple angle. Y is equals to cot inverse of 1 plus cos theta is 2 cos square theta by 2 divided by sin theta is 2 sin theta by 2 cos theta by 2. These are the formula of submultiple angle. Cancel this and this get cancel. Cos over sin is cot. Cot inverse of cot theta by 2. Now cot inverse of cot theta by 2 is theta by 2, so we can write 1 by 2 into theta. Then from the substitution, what is the value of theta? From this, it is 1 by 2 cot inverse of x. Now then derivative, differentiating with respect to x. dy by dx equals to half. Derivative cot inverse x is minus 1 by 1 plus x squared. And the proper answer will be minus 1 over 2 over 1 plus x squared. What answer? Now y is equals to sec inverse of 1 by 2 x square minus 1. Now if it is 2x square minus 1 means that you have to remember that x equals to cos theta or cos 2 theta. I'll consider cos theta or cos 2 theta. I'll consider cos theta and y is equals to sec inverse of 1 over 2 cos square theta minus 1. Y is equals to sec inverse of 2 cos square theta minus 1 is cos 2 theta. 1 over cos 2 theta is sec inverse of 1 over cos 2 theta is sec 2 theta. Sec inverse of sec 2 theta is 2 theta. Then the value y is equals to 2. The value of theta is cos inverse x. Now the derivative, differentiating with respect to x, dy by dx equals to 2 derivative cos inverse x is minus 1 by under root 1 minus x squared, and this is equals to minus 2 over under root 1 minus x squared. This is the final answer. And in case of substitution, first I've given you a substitution, what are the quantity that you have to substitute. I made a mistake over there. Suppose I've given you, in case of 2x square minus 1, if it is this kind of functions, then you have to consider x equals to cos theta or cos 2 theta. You just have to consider this is equals to cos theta. No need to substitute the cos 2 theta. I made a mistake over there. You have to rectify that quantity. Now if it is in terms of 1 minus 2x square, then you just have to consider x equals to sin theta. Last two substitutions, I made a mistake over there. Please rectify. For these two kind of functions, for 2x square minus 1, that you have to consider x equals to cos theta. If 1 minus 2x square, x equals to sin theta. The first one I have given it, that one is incorrect. Okay, now this much will do today, the substitution. Now next video, we are going to discuss the first order derivative, the lengthy chapter only. There's so many things that you have to learn in this chapter. Now in the next video, we are going to do the first order derivative of variable to the power variable form. But till then, you have to practice all these things. Thank you.